In this video, we're going to discuss section 5.2, polar equations and graphs. Let's first start with the definition of polar equations and polar graphs, right? And so when I think about polar equations, I'm thinking about equations whose variables are polar coordinates, right? And remember, all of your polar coordinates come in the form r, theta. All right, and so I want to see r and theta. If an equation is composed of those two variables and their meanings, then I'm going to call that a polar equation, as we discussed from before. The graph of a polar equation, it consists of all the points whose polar coordinates satisfy the equation. Remember, whenever we want to graph something, the purpose of graphing is so that we can see all of the points that satisfy that equation, all of the solutions of that equation. And so down here, I have my polar coordinate system here. I have my pole, which is like the origin from before, and I have my polar axis, which is my positive x-axis from before, right? And of course, we have all of these angles. Now, the way I've set up this polar coordinate system here, you can see these angles. These are in increments of pi over 12, right? So this angle here will be, this angle here will be pi over 12, and I go up by pi over 12 each time. This is one way that I can notate my, or do my increments of my angles here. Or you could do it in increments of pi over 4 or pi over 6, whichever way you want. But this is the way that your textbook kind of sticks with it, and that's the way that I'm going to stick with it as well. Now, our popular angles, kind of like our angles that we talked about with our right triangles and our unit circle, are angles like pi over 6, which will be this angle here. That's 2 pi over 12. 3 pi over 12 is the same thing as pi over 4, so our angle pi over 4 is there. We have the angle 4 pi over 12, which is pi over 3. This next angle will be 5 pi over 12, which is not on my unit circle, right? But there we go. And then we have 6 pi over 12, which is pi over 2. All right? And so I can continue to go, I have 7 pi over 12, 8 pi over 12, which is 2 pi over 3. That's an angle that we know. We also have the angle 3 pi over 4, 5 pi over 6, so on and so forth. I have pi, and you can continue to go, and you'll have all these angles here. And so when I want to plot a point in my polar coordinate system, let's say I wanted to plot the point 2 pi over 3. Okay? Then what I do is, notice this is where my initial side, my initial side of my angle is going to be. Pi over 3, 2 pi over 3 is here. And what I want to do, and what's nice about my polar coordinate system, is you see these circles here. And remember, your r is the distance from the pole to the point, which is also going to be like the radius of the circles that you see in this polar coordinate system. And so if I go up 1, 2, 3 units on that terminal side, I have the point 2 pi over 3. All right, and that's a review of how we graph using the polar coordinate system. Let's actually get to some graphs. In order to graph, right, we're going to go over two methods that we can use to graph polar equations. The first method is to change the equation from being in terms of polar coordinates to write them in terms of rectangular coordinates. So I'm going to go from having a equation written r and theta to having an equation written in terms of x and y. All right, that is our goal. And once we write it in terms of x and y, we can use our x and y plane to graph the points. Let's look at an example. This is my first example. Graph theta equals 3 pi over 4. And the thing you have to remember when you're converting from polar coordinates to rectangular coordinates, there's a couple of things that you can remember. For instance, one thing you can remember is that x equals r times the cosine of theta. We may be able to use that. Y equals r times the sine of theta. Tangent of theta equals y over x. And we can also use that r equals the square root of x squared plus y squared. All right, those are my facts that relates my polar coordinates to my rectangular coordinates. And so if I'm looking at this thing right here and I want to write that using rectangular coordinates, then the thing that has theta, a lot of these things have theta, but I'm going to pay close attention to this one right here. Tangent of theta equals y over x, right? If I can see a tangent of theta, I can change that to a y over x. So what I'm going to do in this polar equation here is I'm going to take the tangent of both sides. I'll get tangent of theta equals the tangent of 3 pi over 4. And with that, we know that the tangent of 3 pi over 4 is -1. And notice here I have tangent of theta, right? I can rewrite that as y over x. Okay. Of course, I can solve this for y to reveal what type of equation this is. Because remember, when we're graphing stuff in our xy plane, we normally solve everything for y, and then that way we'll have our equation as a function of x if it's a function. So I'm going to multiply that equation there by x on both sides, and I get y equals negative x. If you notice, this is the equation of a line, right? All of our equations of lines, y equals mx plus b form. All right, most of them. And m is our slope, which in this case would be -1. Of course, you can write that as -1/1. And your b is your y-intercept. Notice I'm not adding anything, or if you wanted to think, you can be adding 0 to that x there. So my y-intercept will be 0. And so if I think about my xy plane, right, y equals 0 is at my origin, so I'll plot that there. And since my slope is -1, 1, I can go down 1 and to the left 1. And it looks like I'll be on a point about, that is absolutely wrong. I don't want to go down 1 and left 1. I want to go down 1 and to the right 1. And so if I go down 1 and to the right 1, looks like I'll be at about that point right there. And notice here, this point is on, sorry about that noise there, this line right here. All right, and if you think about it, got my graph a little off here. But if you think about this line represents the angle 3^4, right? This angle on my polar coordinate system is 3^4, right? And so you don't necessarily have to use x and y coordinates in order for you to, or rectangular coordinates for you to see this. This line represents all the points in my polar coordinate system that has an angle in their ordered pair, r theta, right? All of my angles come in the form r theta, but it has the theta coordinate of 3^4, and that creates a straight line as if we were graphing a straight line in our xy plane. All right, let's look at another example. This example, we have r equals 4, okay? Now, this time I'm going to think about it before I change it to x and y coordinates. R equals 4. If I'm going to graph this in my polar coordinate system, just thinking about polar coordinates, the thing that I should be thinking about is the line or the curve that has all points that have an r coordinate of 4. All right? So if I think about r and theta, my r is going to be 4 no matter what theta equals. Okay? And if I look at my polar coordinate system, that is actually going to be a circle with radius 4. Because it doesn't matter which angle I have, right? If I have the angle pi over 2, I'm going to have a r equals 4. So I'll get a point like this. If theta equals pi over 4, I'm going to get a r value of 4. And so I get that point there. If theta equals 0, I get an r value of 4. So I get that point there. And as you can see, no matter what angle that I choose, r is going to equal 4 because that's what that equation represents. And so my graph is actually going to be this circle here. All right, another way to think about it is to change it to x and y coordinates. All right. Now, when we go from polar coordinates to x and y coordinates, one thing that we can do is of course, we can take the tangent of both sides, but we don't want to take the tangent of both sides here because I don't have a theta equals. And so one other thing we can do is we can either square both sides or we can multiply both sides by r. What I'm going to do in this example is I'm going to square both sides. So I'm going to raise both sides to the second power. So I get r squared equals 16. By me doing that, I know from previously that r squared is the same thing as x squared plus y squared. So I can write this equation as x squared plus y squared equals 16. And what you should notice is that that is an equation of a circle. It has the form of an equation of a circle, x minus h quantity squared plus y minus k quantity squared equals r squared. All right? Notice with all equation of circles, h, k is the coordinate of your center, and r is your radius. Of course, the equation there has r squared. But notice here, I'm not subtracting anything from x here. And so my h is k, my h is 0. And I'm not subtracting anything from the y here. That means my k is also 0. So my center is at the origin. And my radius, notice that this is my radius squared. So 16 is my radius squared. And the thing that I squared to get 16 is 4. So this is a circle with the center at the origin. And that has a radius of 4, which is, as we can see, is this graph that we have graphed here. All right, and so there's two ways that you can think about that. All right, that is one method we can use to graph polar equations, to change everything in terms and write them in terms of rectangular coordinates. Let's look at an alternative way to graph polar equations. Our second method is to graph by plotting points. All right. And so what we're going to do, right, we'll have a polar equation given in terms of theta, r equals something, something in terms of theta. And we're going to create an XY chart. Since it's given in terms of theta, I'm going to pick points like 0, pi over 4, pi over 2, so on and so forth. And I'm going to plug it into whatever expression I get on that side of my equation. And then I'll be able to find out what r equals here, on this side here. Okay. Now, when we first graph just regular trig functions, where the points that we started at were 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, and those were, those are my quadrant angles, right? Quadrantal angles. When we're graphing polar coordinates, I need to figure out what's going on within each quadrant. All right, not just what's happening at the on my axes here. All right, I need to figure out what's going on in my quadrants as well. And so when I start picking points, I'm going to choose at least one point within my first quadrant, one point within my second quadrant, third quadrant, and fourth quadrants. And I'm going to choose my angles that represent my axes, my quadrantal angles. All right, and so let's look at an example of that. All right, I have r equals 3 plus 3 cosine of theta. And I'm going to go ahead and create me an XY chart and choose my points for my angle theta. So here's my chart. I have chosen my angle 0, pi over 4, pi over 2, 3 pi over 4, pi. And so 0 is here. Pi over 4 would be here. Pi over 2 is here. 3 pi over 4 would be that angle. I have pi. 5 pi over 4. This will be 3 pi over 2. We have 7 pi over 4. And last but not least, we get back to 2 pi. Notice I have my quadrantal angles, and I have at least one angle that's within my quadrant. And these are the angles with reference angles of 4, right? Pi over 4. And so what I'm going to do is I'm going to plug these values into my 3 plus 3 cosine theta here. And I'm going to find what that equals, and that's going to give me the r of all of my points in my that my graph is going to go through. All right. For instance, if I plug in 0 for cosine theta, all right, cosine of 0 is 1, and so if I do 3 times 1 plus 3, I'm going to get 6. All right. Do the same thing for pi over 4. Of course, we know the cosine of pi over 4 is the square root of 2 over 2. But since I'm graphing this, I'm going to use the decimal approximation. And so with that being said, I'm going to go ahead and I'm going to just put that in my calculator so I can get the decimal approximation. And the decimal approximation for that is 5.1. Do the same thing for pi over 2. You don't necessarily need a calculator for that one because the cosine of pi over 2 is 0. And 0 times 3 is 0. But if I add 3 to that, I'm going to end up with 3. 3 pi over 4, plug that into my calculator, I get 0.9. Pi, I get 0. And then what you're going to notice is that we're going to have that same pattern, but going backwards. I'm going to get a 0.9, a 3, a 5.1, and a 6 when I plug that into my calculator. And so now that I have all of these points, remember, our ordered pairs come in the form r theta. And so this point here is going to be the 0.60 radians. This next point here is going to be the 5.1 pi over 4, and so on and so forth. And so what I'm going to do is I'm going to go to my graph and I'm going to start plotting these points. When my angle is 0 units, my radius is 6. So I'm going to go 1, 2, 3, 4, 5, 6, and my point is going to be here. Okay. Power of 4, 5.1. So I'm going to go power of 4. I'm going to go up 1, 2, 3, 4, 5. Go up 0.1. And my graph is going to be here. Of course, my dots are a bit bigger, so they're going to look like they're, since it's a decimal, it's not going to be perfect. But at power over 2, I have a R value of 3, or a radius of 3. And so I have that point there. At 3 power over 4, I have a point radius value of 0.9. So it's going to be close to 1. And of course, I'm going to make this big. All right. At pi, I have a radius of 0. A radius of 0 is just at the pole. So I get a point at my pole, like the origin. 5 pi over 4 is 0.9 as well. 3 pi over 2, you get 3. So 3 pi over 2 is on that negative, at y-axis. So 1, 2, 3. We got to go down 3 to get to that positive 3 there. All right, 7 pi over 4 is 5.1. So 7 pi over 4, 1, 2, 3, 4, 5, and go 0.1. And I have all of these points here, and I'll get back to my original point that I started with when I do 2 pi 6, or 6 2 pi. Okay? And so if I follow these angles here and connect my dots with a smooth curve, I'm going to get a graph that looks something like that. All right? And so that's the graph of my polar equation there. Let's look at one more example of doing this, and then we'll be done. In this example, we have r equals 2 plus 4 times the cosine of theta. Again, I'm going to create me an XY chart. I'm going to use those exact same X and Y coordinates. And then with those, I am going to plug those angles theta into my r equals 2 plus 4 cosine of theta to find my r, or my radius. And then I'll plot those points. And so if you go ahead and do this, you can pause this video, see if you can do it on your own, and then come back and see if you've gotten it correctly. So pause the video and see if you can do this on your own. All right, and so if you plug in those values for theta, evaluate it in your calculator, you'll get these outputs here, round it to 1 decimal place. And so what I'm going to do is I'm going to go ahead and start to graph, right? I get the 0.60 radians, right? So I go to 0 radians, which is my positive x-axis on, in my xy plane. And I have a radius of 6, so 1, 2, 3, 4, 5, 6, and I have that point there. I have pi over 4, 8. Remember, pi over 4 is this angle here. And I have 4.8, I'm sorry. And so I go up 1, 2, 3, 4, and 0.8. And I get to a point that looks to be sort of right there. I have the point pi over 2, or 2 pi over 2. So my angle pi over 2 is here. And I want a radius of 2, so I go up 2. I have 3 pi over 4 negative 0.8. The angle 3 pi over 4 is here. And remember, whenever we have a negative radius, instead of going up towards this angle this way, since it is negative, the way our polar coordinate system is defined, we have to go in the opposite direction, which is that way right there. All right, so I've got to go that direction, 0.8 units. And so I have an angle that looks to be right here. And I know this is close and everything, but there we go. And so somehow my graph is going to be going from this point to this point, but it has to get to this next point right here. All right. What you're going to have to notice is how it's going to do that. And the way it's going to do that is to go through the origin. And the reason that I know that is to look at this equation here, okay? If I look at this equation, if any point goes through the origin, it has to have an r value of 0, right? And so if I think of this equation as 0 equals 2 plus 4 times the cosine of theta, and if I were to solve that for theta to figure out the angle that produces an r value of 0 for this equation here, I can just solve for cosine of theta, right? And then solve for theta. I'll subtract 2 from both sides. I get negative 2 equals 4 times the cosine of theta. Divide both sides by 4. I'm going to get a negative 2 over 4, which is negative 1/2, equals the cosine of theta. And if I think about it, the angle who has a cosine value equal to -1/2 is 2 pi over 3, right? Remember, 2 pi over 3 is over here, and that's the angle where I get a 0 here, all right? And so what that tells me is that what I'm going to have here is I'm going to have my angle, or my polar equation graph, going like this. All right, it's going to go through the origin, and then it's going to get to that point there. All right, let's go ahead and graph the other points. My next point is the point -2 pi. My angle pi is over here. Remember, I go this way 2 units if that was a +2, but since that is a -2, I've got to go in the opposite direction. And so I get the point right here. The point -0.85 pi over 4, 5 pi over 4 is here. Again, if that was a positive 0.8, I come this direction. Since it is a negative, I got to go in the other direction. And so I get a -0.8, which will be right there. And so what my graph is doing is it's looping around. It's looping around to get to that point there. Sorry about that. All right. And there we go. And then if I graph the rest of my points, at the point 3 pi over 2, notice 3 pi over 2 is down here. 2, I go 1, 2. I get that point. And I'm going to go ahead and plot these points before I continue to draw the graph. 7 pi over 4 is this angle here. I get 4.8. So that's 1, 2, 3, 4, go 0.8. I get here. And 2 pi is my angle, the radius is 6, and I get back to my starting point. And so if I continue to complete my graph, I'm going to get a graph that looks like that. All right? And that is how we graph polar coordinates by plotting point. And we also seen how we can graph them by changing to rectangular coordinates. That concludes this video.